All right, boys and girls, on this video, we're going to look at dividing decimals using area models. And so you're going to see a lot of similarities between multiplying decimals and dividing decimals. And really and truly, when you work on these, a lot of times I tell my students, especially with the models, you're really thinking about what's called the inverse operation. And so the inverse operation would be kind of like the opposite. So, a lot of times as you are in, fourth and fifth grade, you might think, okay, well, the opposite of multiplication is division, or the opposite of division is multiplication. And you can kind of, basically check your work by doing that. And it's very true, especially when you look at these models. And so you might see a lot of the same things that you've already done. You might see a lot of the same type of models. You might just now start seeing them more in a division problem. And so if the multiplication models made sense to you, then the division ones are going to make sense as well, because basically they're the same thing. It's just the opposite. A lot of times I tell kids it's kind of like when you read a word problem and you're deciphering on what type of problem it is and what to do. You look for things like, okay, well, maybe they're looking for a total. Well, if they're looking for a total, then you might have two parts, and those parts multiplied together will give you the total. Well, now it's kind of like, well, I'm going to look at this model, and I have a total, and I want to see what are they doing to that total? How are they breaking it up? How are they breaking it into the parts? And so that's how I'm going to start on this page. So if you look, this page here has a couple of models for you. It actually has two problems. It's problem 5 and problem 6. We're going to start on problem 5. And so the first thing I would want a kid to do is just to kind of break this down and see what you see and kind of think about what you're seeing here. So I see that there is, and I'm going to use my pen here, there's one hole here. Oops, let me get my pen turned on here. All right, I think it's ready. All right, so I see one hole here, I see another hole here, and then I see part of a hole there. And so if I really wanted to break this down, I could think, okay, I know it's 2 and something. That third hole is not completely filled in, but if I were to go count it, I would count 1, 2, 3, 4, 5, 6, 7. 7 of those columns are shaded. And so I could say, I think safely, I could say that there are 2 holes and then there's 70 hundredths shaded. Okay, so that's one thing that I see. Something else that I see is, and I'm going to switch colors here, I see that they have circled basically 2 groups, and I'm going to outline that in my red. And so they've circled a group here, and then they've circled a group here. And so now I can look at it and go, okay, well, I think they gave me a total 2 and 70 hundredths, and they basically just split it into 2 parts. And so now I could think to myself, I think this problem is simply just going to be 2 and 70 hundredths divided by 2. Well, if that was the case, if that's really, what's going on in this picture, which I think it is, there's really a couple ways to go find your answer. You could find it by counting up, and you can basically count to see what is in each group. Or honestly, what I would suggest doing for my students is, after you analyze and you know that this is it, I would probably just solve. And so I would set up this algorithm. I would set up 2 and 70 hundredths, and I would just divide that by 2, and I'd go get my answer. I'd find out, what is the final answer here. And really, when you write that problem out, it kind of just looks like $2.70 divided by 2. Again, this has nothing to do with money, but it could very well easily be a money problem. So if I wanted to do this, I would take my decimal straight up to the top, and then once that's done, I just start dividing. I don't let that decimal bug me. I just go about my business and divide. So 2 can go into 2 one time. 2 goes underneath. We're going to subtract. There's nothing left over. I'm going to bring down the 7. And so 2 can go into 7 3 times. 3 goes up at the top. So 6 goes underneath. And I'm kind of running out of space there on the side, but I think I could finish it off. My last problem would be, how many times can 2 go into 10, and that would be 5. And so I wouldn't have anything left over here. I basically would have an answer of 1 and 35 hundredths. Okay, so now what I want to do is I want to go back and I basically want to, oops, didn't mean to do that. All right, sorry about that. I think I got it fixed now. So now I'm going to look at this model and I'm going to think, okay, where can I find that answer of 1 and 35 hundredths? So I had to erase it, so I'm going to write it up here at the top. I got to really shrink my pen down here. Okay, so 1 and 35 hundredths. So where I could find that is in each group, I should see 1 and 35 hundredths. So in this group here, I'm going to outline a few things with blue. I can circle this and I could see if I really count this up, I could see 50 hundredths here. If I wanted to go count all that up, that'd be 50 hundredths. Okay, and then I have another group here, and then that also would be 50 hundredths. And so if I added that together, 50 hundredths and 50 hundredths, that gives me my 1. That's where that comes from. And then here on this last one, I could count it and I could see 35 hundredths. And so really and truly, if I put it all together, just in this first group, I'm going to put a check off to the side, I have 1 and 35 hundredths. But I have it twice, basically. So I have another 1 and 35 hundredths underneath it. And so that's where, if I go back to this whole problem, they started me at 2 and 70 hundredths, but then they split it into 2 groups. And so I can, kind of safely say now that I've checked it, I could say that, all right, this problem here for problem number 5 is going to be 2 and 70 hundredths, and then they divided it by 2, and they got an answer of 1 and 35 hundredths, or that's at least in what's in one of the groups. Okay, so let's look at problem 6. Problem 6 is a little bit different, and that's because when you start looking at problem 6, you're looking at a different type of grid. The top grid is a hundredths grid, or they have hundredths grids up there, but now you're looking at tenths grids. But really and truly, the math stays the same. When you're looking at this, you're still thinking, okay, hey, if I really were to go and solve this problem, or if I'm looking for what they did, I need to start with, okay, well, what did they give me? And so I'm going to kind of break it apart step by step. If I look at the tenths grids, it looks like they have one hole here, they've got a second hole, and then they've got part shaded on the last one. So I see 1, 2, 3, 4, 5, 6, 7, 8. So I feel like this whole thing is 2 and 8 tenths. So I'm going to write that out to the side. I think 2 and 8 tenths is the whole picture there. But then if I look carefully and I look at their groups, it looks like they've split it up into 4 groups. And so I'm going to circle them. There's 1, there's 2, there's 3, and then there's 4. And so if I wanted to, make a problem, to come up with an expression or an equation for this problem, for this model, I would say, okay, well, you know what? I think they just took 2 and 8 tenths and they split it into 4 groups. And so maybe I just have something as simple as that, 2 and 8 tenths divided by 4. Which really, when that comes down to it, I would hope most students would see this as basically just a math fact. I mean, it's just a math fact. It's 28 divided by 4. Well, 28 divided by 4 is just 7 if you know your math facts. But you got to be careful, because if you're going to divide with decimals, you're going to bring that decimal up to the top. And then now when you divide 2 and 8 tenths divided by 4, you're saying that 4 is going to go into that 8, or it's going to go into 28. And so you're going to get the same math fact there, but your answer is not 7, your answer is 7 tenths. And then if you really wanted it to click and for it to make sense, just go look in one of their groups. Like I'll kind of just show right here with an arrow. Look at this first group here. They've shaded 1, 2, 3, 4, 5, 6, 7. They've shaded 7 tenths. So basically, if I were to think about this now, I see all the parts. I see the whole thing being 2 and 8 tenths. I see that they circled it, or they grouped it into 4 groups, and then in each group I see 7 tenths. And so really thinking about this now and kind of seeing 2 examples, a lot of it is very similar to your multiplication problems. Your multiplication problems, very easily could show up on this page. I mean, think about the last example, problem 6. They could flip this around and say, well, hey, this could be a model of 7/10 times 4, and you could be looking for 2 8/10 as the answer. Or they can flip it and say, okay, well, here's the total. Here's 2 8/10. Let's split it into 4 groups. What's in each group? Well, if they do that, then you know that there's 7/10 in each group. So it's really important to see it both ways, because on a test, they could show it to you both ways. Or like, possibly on the STAR test at the end of the year, you might have one problem that's a multiplication problem. It's it's an area model for multiplication. Then you might go, 2 or 3 pages down on your test, and then, hey, there's one, but it's for division. So you have to be prepared for that. You have to know both ways. But again, ultimately, you're dealing with the same math here. It's just what's called the inverse operation. The opposite of multiplication is division. The opposite of division is multiplication. Okay, so I hope these couple examples helped. You never really should see a thousandths model with this. So you're pretty much going to stick to either hundredths grids or tenths grids. Thousandths models are just too hard to read. They're too, the spaces are too small. And so you could pretty much just guarantee yourself, being one of these two here. So look at these two, watch this video again if you need it to be broken down. But pretty easy stuff here. I think this is pretty simple for you.